When you look up at the night sky, you may notice stars shining like tiny lanterns in the darkness. Some stars are bright, some are faint, and some are so far away that their light takes thousands of years to reach your eyes. The sky feels peaceful, quiet, and full of familiar shapes. But hidden in that peaceful darkness, there are places where the rules of the universe bend in ways that are almost impossible to imagine. These places are called black holes. A black hole is not a hole in the way you know holes. It is not an empty tunnel. It is not a gap in space. A black hole is the heaviest, strongest, most powerful object the universe can create. It is a place where gravity becomes so strong that nothing can escape. Not planets, not rocks, not dust, not even light. When light cannot escape, the object becomes invisible. That is why we call it a black hole. It is black because no light can come back out. Gravity is the force that keeps your feet on the ground. It keeps the Earth circling the sun. It keeps the moon circling Earth. But inside a black hole, gravity does not behave in the gentle, familiar way you know. Instead, it becomes wild and intense. It becomes so strong that it pulls everything inward with unstoppable force. It bends space. It stretches time. It changes the universe around it. The idea of a black hole may sound frightening, but it is also one of the most beautiful ideas in the universe. Black holes show us the limits of what we know. They show us the edges of physics, the boundaries of reality, and the places where human understanding begins to fade. Black holes remind us that the universe is much stranger, deeper, and more mysterious than our everyday world suggests. But here is the most important part. Black holes do not simply appear out of nowhere. They have a beginning. They have a story. They are born from stars, just like the stars that shine above you at night. A black hole begins as something familiar, becomes something extraordinary, and ends as something that defies every rule we understand. Before we can explore what happens inside a black hole, we must understand how one is created. We must understand the birth of something so heavy that it collapses under its own weight. We must understand how a star, which gives light and warmth, can become an object that lets no light escape at all. The universe is full of wonders, but few wonders are as powerful as the birth of a black hole. Black is one of the rare moments where the universe takes something bright and beautiful and transforms it into something dark, silent, and endlessly fascinating. This is where our journey begins, with a star, with a collapse, with the creation of the darkest place in the universe. To understand what happens inside a black hole, you must first understand how one begins. Every black hole starts its life as a star, not a small star like the sun, but a giant star, many times heavier and larger. Imagine a star so massive that if it replaced our sun, it would stretch far beyond the orbit of Mercury and Venus. These enormous stars burn hotter, shine brighter, and live faster than ordinary stars. They are powerful, but they are also fragile in a way that is difficult to see. Inside every star, there is a battle happening quietly. The star shines because it is constantly performing a reaction deep in its core, turning light elements into heavier ones. This reaction creates energy. That energy pushes outward and keeps the star from collapsing under its own weight. At the same time, gravity pulls inward, trying to squeeze the star into something smaller. The outward push and the inward pull balance each other perfectly. This balance keeps a star alive. But nothing lasts forever, not even a giant star. As the star ages, it begins to run out of fuel. It burns through its energy faster than it can replace it. The outward force becomes weaker. The inward pull becomes stronger. And slowly, the balance breaks. When gravity finally wins, the star begins to collapse. This collapse is incredibly fast. It does not happen over centuries or years. It happens in seconds. The outer layers of the star fall inward with tremendous force. The core of the star is squeezed tighter and tighter until atoms are crushed together. The pressure becomes so intense that the core cannot handle it. The star explodes outward in a brilliant flash called a supernova. A supernova is one of the brightest events in the universe. For a moment, a single exploding star can shine brighter than an entire galaxy. But while the outside of the star bursts outward, the core continues to collapse inward. It becomes smaller, heavier, and denser at every moment. All the mass that once filled a giant star is now shrinking into a tiny point. Imagine something as large as a star being squeezed into something smaller than a grain of sand. Imagine all that weight concentrated in an unimaginably tiny space. The result is a black hole. A black hole is not made of normal matter anymore. It is not made of gas or fire. It has collapsed to a point where the laws of physics begin to shift. The mass remains, but the space it occupies becomes almost nothing. Gravity grows stronger with every bit of shrinking, until it becomes so powerful that nothing can resist its pull. This point is called the singularity. It is the center of the black hole. It is the place where all the mass is crushed into a size that human minds cannot picture. Around this point lies darkness, silence, and a boundary from which no object can return. Even though black holes form from stars, they do not look like stars at all. They do not glow. They do not shine. They do not give off light in any direction. Instead, they become invisible, except for the way they affect the world around them. They pull on nearby stars. They bend the light passing by. They twist space and stretch time. They turn their region of the universe into a strange, distorted place. Some black holes are small, created by the collapse of only one star. Others are enormous, millions of times heavier than the sun, sitting in the centers of galaxies. These supermassive black holes were formed long ago, and they have been growing for billions of years, pulling in gas, dust, and even entire stars. Every black hole, no matter how large or small, begins with the same story. A star that lived brightly. A collapse that happened suddenly. A point of gravity so strong that it changed everything nearby. Now that you understand how a black hole is born, you can take the next step. You can approach the boundary that surrounds it, the place where falling in becomes unavoidable. This boundary is called the event horizon, and it is one of the most mysterious edges in the universe. Once a black hole is formed, it does not look dangerous from far away. It does not glow. It does not flash. It does not roar. It simply sits in the darkness, silent and invisible. But surrounding every black hole is a boundary that is unlike any boundary in the universe. This invisible line is called the event horizon, and it is one of the most important ideas in all of physics. To understand the event horizon, imagine standing beside a calm river that suddenly becomes a large waterfall. At first, the water near the top is peaceful. If a small leaf floats in that area, it can drift away freely. But as the leaf moves closer to the waterfall, the water grows faster and stronger. There is a point where the water becomes so powerful that anything crossing that line will be pulled over the edge, no matter how much it tries to fight. Once past that point, there is no way back. A black hole works in a similar way. The space around it is calm at first. Planets, gas clouds, and even light itself can pass by safely if they keep enough distance. But the closer you move toward the black hole, the stronger the gravity becomes. It pulls and stretches everything near it. There is a point where the pull becomes unstoppable. If anything crosses that point, it cannot escape, not even with the speed of light. That point is the event horizon. The event horizon is not a wall or a surface. There is nothing to touch, nothing to see. It is simply the last place where escape is possible. On one side, light can still travel away. On the other side, light is trapped forever. It is a one-way door. You can enter, but you can never leave. Imagine shining a flashlight toward the black hole. If the light is outside the event horizon, it can still move away into space. But if the light is inside the event horizon, it bends inward and disappears. This is why black holes look black. No light escapes from inside that boundary. The event horizon hides everything that happens behind it. To understand how strange this boundary is, imagine you are floating far above a black hole, watching someone else drift slowly toward the event horizon. You would see something unusual. As the person moves closer, their movement would appear to slow down. The closer they got to the boundary, the slower they would seem. Time itself would stretch. If they reached the event horizon, they would appear frozen in place, trapped at the edge forever. You would never see them fall inside. But from the person's own view, something very different would happen. They would not feel time slowing. They would not feel anything special at the event horizon. They would fall through it as easily as stepping through open air. There would be no sound, no flash, no barrier. They would simply continue falling. This difference between what an outside observer sees and what the falling person experiences is one of the strangest effects of gravity near a black hole. Time does not behave the same way for everyone. Distance does not behave the same way. Space stretches. Clocks slow. Reality becomes flexible. Once something crosses the event horizon, it is pulled inward with absolute certainty. There is no force strong enough to stop the fall. There is no possibility of turning back. Every path, every direction, every future moment leads toward the center. The event horizon is not dangerous because of what it does. It is dangerous because of what it does not allow. It does not allow escape. It does not allow return. It does not allow information to leave. It separates the universe into two parts: the outside world, where light and time behave normally, and the inside, where everything changes. Now that you have reached the edge of the black hole, the next step is the fall itself. It is the moment where gravity becomes overwhelming, where time twists, and where the human body begins to stretch in ways that challenge imagination. This is the journey past the point of no return. Now that you have crossed the event horizon, the fall toward the center of the black hole begins. It is not like any fall you have ever imagined. There is no sense of wind. There is no feeling of speed. There is no sound. The fall is silent, smooth, and unstoppable. Gravity is in complete control, guiding you inward with a force that grows stronger every moment. At first, you might not notice anything unusual. If the black hole is large, you could drift past the event horizon without any pain, any pressure, or any sudden change. The crossing itself feels empty, almost gentle. The strangeness begins after you have already entered. Imagine that your feet are slightly closer to the center of the black hole than your head. Gravity at your feet becomes a little stronger than gravity at your head. This difference becomes bigger and bigger as you fall. It does not pull you downward like a normal fall. It stretches you, slowly at first, then more intensely. Scientists call this stretching tidal force. You can think of it as a cosmic tug of war. The gravity near your feet is pulling harder than the gravity near your head. If the black hole is small, this stretching becomes violent very quickly. Your body would be pulled long and thin before you even reach the center. This process has a dramatic name. It is called spaghettification. It sounds like a joke, but it describes something real. The pull is not like a hand grabbing you. It is gravity grabbing every atom, every piece of you, every part of your body at the same time. It stretches you until your shape begins to change. You become longer, thinner. As time passes, the stretching grows even stronger. But something even stranger happens to time itself as you fall. For an outside observer, your time begins to slow down dramatically. Someone watching from far away would see you drift slower and slower as you approach the event horizon. Once you crossed it, you would seem frozen in place. Your last visible moment would stretch into eternity. But from your own view, time continues as normal. Your heartbeat stays steady. Your thoughts move forward. Seconds pass the way they always do. You do not feel frozen. You do not feel slowed. You are simply falling inward, while the universe outside you rushes forward at unbelievable speed. The deeper you fall, the more extreme this effect becomes. Space around you feels like it is stretching. The light from the outside world grows dimmer. Colors shift. Shapes distort. The stars you once saw above you begin to smear into bright arcs of light. The universe outside appears to speed up, as if time is running forward faster and faster. Eventually, the pull becomes so strong that even the light inside the black hole bends and twists around you. You fall faster, not because you are moving on your own, but because space itself is falling with you. Inside the event horizon, everything is collapsing inward. There is no direction except toward the center. As the tidal forces grow stronger, your body's shape continues to change. You stretch into a thin, long line, pulled tighter and tighter by the increasing gravitational difference. In a small black hole, this stretching would tear your body apart quickly. But in a supermassive black hole, the stretching might be gentle for a long time before becoming intense. The fall into a supermassive black hole is quiet and almost peaceful at first, with the danger building slowly. There is no way to avoid the center. Every possible path leads inward. Every moment brings you closer. Every movement is controlled by gravity. This is a place where human ideas of motion no longer work. You are not falling into a black hole. You are falling into space itself, being pulled inward. And at the end of this journey lies the singularity, the most mysterious point in the universe, the place where no theory has ever fully explained what happens. This is where you go next, into the unknown. You have passed the event horizon. You have fallen through the silent darkness. You have felt the pull of gravity grow stronger with every moment. Now you are reaching the final and most mysterious part of the journey, the inside of the black hole. Inside this region, the rules of the universe begin to change. Not slowly, not softly. They change completely. The laws of physics, the laws that shape everything you understand, time, space, motion, and energy, begin to bend in ways that no scientist has ever been able to observe directly. This is because no information from inside a black hole can escape. No signal can leave, no message can be sent, no measurement can be made. The inside of a black hole is a place hidden from the universe itself. At the very center of the black hole lies the singularity. The singularity is not a place you can stand. It is not a surface. It is not a point you can see. It is a region where everything that fell into the black hole is crushed into infinite density. All the mass of the star that collapsed, plus everything the black hole consumed afterward, is squeezed into a space smaller than imagination. In normal space, if you squeeze something, it pushes back. A rock resists pressure. A diamond resists pressure. Even the densest materials in the universe can push back to some degree. But inside a black hole, gravity becomes stronger than every force that holds matter together. At the singularity, nothing pushes back. Everything collapses. Time also collapses. Space collapses. Direction collapses. There is no left or right, no up or down, no past or future in the way you understand it. Inside the black hole, the idea of moving forward in time becomes the same as moving toward the singularity. The singularity is not just a place you fall into, it becomes your future. Every moment inside the black hole leads toward it the way every moment outside the black hole leads into tomorrow. And yet, even with all of this, the singularity remains one of the greatest mysteries in science. Some scientists believe that the singularity is a real physical point of infinite density. Others believe that this is simply a sign that our current understanding of physics is incomplete. They think that when we finally discover a new law of nature, the singularity will not be a single point, but something else entirely, something that we cannot yet imagine. There are theories that suggest the inside of a black hole might open into another part of space. There are theories that suggest it might open into another universe. There are theories that believe the singularity could be a gateway, a bridge, or a boundary between realities. These ideas are not proven. They are guesses based on mathematical possibilities. But the fact that such possibilities exist shows how mysterious black holes truly are. Even the way black holes hold information is confusing. When something falls in, does the information about what it was disappear forever? Or does it remain on the surface of the event horizon in some hidden form? This question is one of the biggest puzzles in modern physics. It is called the information paradox, and no one has solved it yet. What we do know is this: once inside, nothing returns. Once inside, space and time become something new. Once inside, the universe as you know it ends. But even though the inside of a black hole is frightening and unknown, black holes are not enemies of the universe. They are part of its design. They help shape galaxies. They help stars form. They recycle matter. They influence the growth of the cosmos. Black holes are not mistakes. They are features of a universe that is stranger and more beautiful than anything humans have ever built. Now that you have seen how a black hole forms, how its edge works, how the fall happens, and what lies inside, there is one more step to take. You must understand why black holes matter, why they exist, and what they reveal about our place in the universe. Now that you have reached the end of your journey, you can see black holes in a very different way. They are not simply dark pits scattered through space. They are not monsters waiting to swallow stars. They are not mistakes or accidents. Black holes are part of the universe in the same way mountains, oceans, and stars are part of Earth. They play a role in shaping everything around them. Every black hole begins with a star. That star lived, shined, warmed its planets, and filled its part of the galaxy with light. When its life ended, it collapsed and transformed into something new. It became a region where gravity grew stronger than anything else in the cosmos. This transformation is not destruction. It is a step in the cycle of the universe. Black holes influence their surroundings in powerful ways. At the centers of most galaxies, including the Milky Way, there is a supermassive black hole. These enormous black holes help hold galaxies together. They affect how stars move. They shape the flow of gas and dust. Their existence helps create the structure of galaxies that fill the universe. Without black holes, the universe would not look the way it does. Black holes also teach us about the limits of our knowledge. They show us where our understanding ends. At the event horizon, the rules of physics begin to bend. Beyond it, they break. At the singularity, our current theories stop working. Black holes remind us that the universe contains mysteries that are deeper than the deepest ocean and larger than the largest galaxy. They challenge us to learn more. They show us that curiosity is not a small thing. It is one of the forces that moves the human mind forward. Black holes are also reminders of how connected everything is. The matter that falls into a black hole does not disappear from the universe. It changes form. It becomes part of the black hole itself. Over billions of years, black holes can grow, merge, and release energy in ways that affect everything around them. They are part of the cosmic cycle that began long before Earth formed and will continue long after our planet fades. In the end, black holes reveal something important about you. You are part of a universe that is far bigger, stranger, and more powerful than anything your everyday life suggests. You are made of atoms that were born in ancient stars. The iron in your blood and the carbon in your cells were created in explosions that shook the sky billions of years ago. Even the existence of black holes is connected to you because the universe that created them also created the world you live in. You began this journey by looking at the night sky, wondering about a dark place where light itself cannot escape. Now you have traveled through the birth of a black hole, crossed the edge of no return, fallen through the darkness and reached the mystery that lies inside. Black holes are the universe reminding us that there is always more to learn. There are always deeper questions. There are always new wonders waiting beyond the limits of what we understand. You are small in the face of the universe, but your ability to explore, imagine, and understand makes you extraordinary. You carry the curiosity that allows humans to see further into the cosmos than ever before. The universe is full of light, full of darkness, full of mystery, and full of beauty. And now, you understand one of its deepest secrets a little more clearly.